Welcome back to Goliath. Today we're going to be going over yet another part family that we're adding to the Bluetooth Cloud capability of Goliath. That means today Mike is going to show us how a new chipset works with Zephyr and Goliath. Hey Mike, how you doing?
I'm doing pretty well. How are you, Chris?
Yay, good. I am excited. Another one this time is Renesas, right? Renesas or Dialogue, kind of a dual part
So
family
this
thing.
is it. It says dialogue on it. You probably can't read that with my fixed focus camera, but it is a Renesas part. It is the DA14695 HQ Dev Kit USB. It's a little USB dongle you can plug
Form
in.
factor, yeah.
Yeah, so I gave it a little of a pre-run, and I got stuck for a little while because it can run on 5 volts or 3.3 volts, but Zephyr doesn't seem to like the 5 volts. So make sure you move your jumper over to the 3.3 volt supply, and that'll get it working just great on Goliath. The behavior I was seeing before is it didn't seem like the system clock was running. So I bet there's just some kind of Zephyr configuration in there. But with that resolved, we should be able to get this up and onto our Bluetooth fleet.
I do see a familiar form factor on that, what is actually a USB stick, but it looks like there's a click header on there too.
Yeah, so I did solder 2 of these on. I've got these microelectronica click. This is a Bosch BME 280 sensor. So if we don't take too long in figuring out how to get this onto the fleet, we can then also try add actual sensor data rather than simulating it in code.
Yeah, it's always nice to have those kind of standardized footprints so we can plug stuff in.
Yeah, absolutely.
Like you said, let's get it talking Bluetooth first and foremost.
Yeah, so I'm on the Bluetooth private access for Goliath. This repo is public, so you can go and look at it. But to get the features on the cloud turned on, you do have to go through our enrollment form, which is pretty easy. So do that and give it a try because this stuff is cool. I have here a gateway device. This is one of the 2 that we have pre-compiled for you to use. This is a NRF 9160 DK board from Nordic that has both a Bluetooth chip and a cellular chip, so it will bridge your Bluetooth fleet to the network over cellular. And that's already flashed. You can go back and look at some of the other videos for that. But the next thing that I like to do is just jump into the Zephyr documents for the device. And it does a couple of things. One, you can take a look at the board right there. Here's that dialogue in the copper that I was talking about before. Here's our jumpers. You can see the 2 pins right here are set for 5 volts. I needed to move it to these 2 pins right here for 3.3 volts. And then I've soldered headers onto one of these. I'm going to grab the name here, and we're going to go into our Bluetooth private access and see if we can get this to build. So there we go. So a couple things you'll notice on here, it has the wrong part number because by default, it's going to build for the Nordic NRF 52840 DK. So let's change that to this part number, little trailing leading spaces. And then the other is this replace me down here. And in this case, if you read the README file that's in this Bluetooth private access, it tells you that it wants you to replace that with a, I think I'm going to make a new device just for this call. So let's call it Renesas demo board. And it's going to give us credentials that we don't actually need because we're going to use our device ID in this case. And we'll go back here, and in the replace me section, there's our device ID. So that should be everything that we need, except we're probably going to get a big wah-wah when we try to find this board. So what this is telling us is that we don't have the header files for this board, and that's because we are using an allow list. We got this like last week as well. If I go into the pouch directory to this West file right here, we can see that HAL Nordic's the only one that I have in here. And so let's do HAL Renesas. I think that's what we need.
And you had also said last time when I was dealing with this is that you could just always delete that, delete all of them, delete the allow list entirely, and that would probably wipe out the need to filter down. So
yeah, because what Zephyr's doing here is this import command says go into this GitHub repo right here and look for a west.yaml and then get all that stuff. And then we're using this name allow list to say except only get what's on this list. So we added that one, and we'll do a west update. And there it's getting the Renesas right there. Usually doesn't take too much time. There we go. And we can try and let's do a clean build again. So we didn't get very far last time. What are we missing? libcmac. All right. Missing or no rule to make it. I'm guessing that this is a west fetch blobs. West blobs fetch?
Yep.
Renesas. So some of the vendors, oh, and look, it did it already. So fetching blobs. So there's just a tiny little blob for that one. Some of the vendors will tell you, like, type this command, and other vendors like this one, you just kind of have to intuit. And it did take me a little bit of time to figure out what it was asking. I don't know. I guess I've just done enough of it that I know these patterns. And there we built
those kind of cryptic messages on. It's not like it didn't tell you, use the blobs like you said for the RW612.
Right? Yeah. libmac. Yeah, it's really hard to know. I don't know. I think on this page, let's see. Yeah, and it doesn't tell you on this page, which is kind of hard. The other thing is, so yeah, it just tells you to build and then flash. It'd be nice if it told you needed the blobs. Well, only if you're using Bluetooth stuff. In fact, I'm going to go into that in a sec. The board definition for this one I found out is not set up for Bluetooth, so we got to do a little extra stuff. So Easy Flash CLI they link to from here, and I love this that all you have to do to install this is a pip install Easy Flash CLI. And since we're already using Python with this project, that's like pretty handy. So I've already done that, and so in that case, we can just plug this in. Maybe. Oh, you know what it is? It's one of those USBs that goes one way, not the other.
The old school way.
The old school, yeah, there you go. And we have Minicom up here. And we'll see. All right, so no HCI driver registered, Bluetooth init failed. So that's always a fun one. But if you go in and look at the board definition that was put together in the build, so we go into Zephyr and Zephyr.dst, and we search for HCI, we can see that it's disabled here. So that kind of tells you that they weren't really ready for this to do what you thought, any of these Bluetooth things. So what I'm going to do is just grab out, so we're actually building an examples, and let's add a board file here called DA14695. What is the name of this board? Is that enough? There it is. I probably got that right from up here. Yeah, so I just grabbed the file name up here, which is basically what I'm going to do now. So let's put that in .overlay. And then in the overlay, we're just going to grab this chosen. And we're going to need something like a Zephyr BTHCI. I think is how it's done. I'm just going to cheat and actually look at how I did it before. Oh, yeah. So BTHCI DA14695. Let's see. That's probably in this board file we're just looking at. So it's this one right here. So I'm just going to grab this from the what we see from the board definition, and we're going to set that in our chosen right here. And that's a pointer. So we're going to point to that. And then we also need to turn it on. So it was disabled before. The two things that we can see that these would be is either status equals disabled or status equals okay. So we just need to set the status to okay on this. And again, that's a pointer. And I think that's it. Let's see if it builds. And I probably need to do, since that file wasn't there before, I probably need to do a pristine build. I'm going to give that a try. I'm suspicious that I made an overlay file and it didn't fail the first time. Hey, there we go. All right. Sysrand get. All right. I think I probably had an issue before with this being on Zephyr 4.0. So I'm going to update it to Zephyr 4.1 and see if we have a better time building. It's a little slow. It's slow when you delete the whole chip, that's for sure. All right, advertising successfully started. And then I think we're online. Let's look here at our devices. NRF 9160 was online 4 minutes ago. Oh, there it goes. All right, so just read from it. And if we go to our network topography, now we can see the one we made was Renesas BLE demo. And so if we go and look at that, here it is. And we just got some data.
All right.
Woohoo. So I'm pretty excited about that. There are those maybe 3 or 4 configuration issues to work through with the new board that weren't too bad, but probably took me a couple hours total to get through. The thing is, though, I always like to go a little further than this, Chris, because this is just generic information. Do you think we should try the BME 280?
Yeah. I mean, as long as you've already got I2C in there, so I think it's just going to be an overlay, and then you'll be off to the races, right?
I think not only do we have I2C, but they have the definitions in the board for the click header. So
that's really nice.
Yeah, and so I just kind of looked that stuff up, and you can see here. So it's got a microbus, and it also has a microbus slot 1. But basically, I'm just going to take our bog standard BME 280 definition and put it onto the bus that's already existing. So that same overlay file that we had before, we can just add another node to it. And so just to go over this, this is the pointer. So you know that microbus I2C already existed. And then this is the new node that we're adding. And it declares this compatible, this Bosch BME 280 for the driver that's in Zephyr. So we don't have to do anything kconfig wise to turn this actual node on, but we do need to add some kconfig symbols like to make sure that the I2C is turned on and that our sensors are available. And so let's just kind of go over that real quick. I'm going to do it in the PRJ. You could do this in another board file, but we're going to change main.c, so it makes sense to do it here. So let's just make sure, I don't know if I2C is on or not, but let's make sure to turn it on. And since we're in development, let's turn on the I2C shell as well. And then we're going to use a sensor. So let's turn on the sensor library. And same way, let's turn on the sensor shell. And then I might just want to build. Yeah, pip install easy flash CLI or easy flasher CLI is what it was. Okay. All right, let's try it this time. Oh no, yeah, there it is at the bottom, BME 280 active, and then we can do a sensor get BME 280, and then there are our 3 channels of the sensor. So when the sensor's all working, the rest is just C in order to grab that stuff. So, oh man, I should have had a cheat sheet up for this. Chris, do you have the link to your demo? That is that a public repo? All right, so I'm just going to use Chris's cheater here. Maybe.
It's the finest artisanal code that I could steal from Mike, who wrote it originally.
We all steal from each other, right?
That's right. It's not stealing, it's collaborating.
Here, this is what I want. All right, so we'll start with so here I'm going to actually get any Bosch BME 280 out of the device tree and call it BME dev. And then kind of surprised there aren't any. So this is Zephyr. We're going to do sensor. I think that's it, right? Do we need device as well? We might need device. So what I'm going to do is fetch the sensor samples from my device called BME dev. And then I am going to use the sensor channel get in order to pull out some struct sensor value. And we're going to call these temp, pray, and hum. And I'm going to change these to BME.
You could have stolen this from the main.c that I had there, huh?
Oh, did you already have it there? In main.c?
Yeah, sort of. It was a little bit different. I was just a fetch. I do a fetch right from one of the public functions. Go back up. Not a fetch, sorry. Just right above the send. It does a get latest, I think. There it is. Get latest weather.
Get weather.
Yeah.
Aha.
And then I just shove that buffer into the pouch right below it.
Right. But then I need to pull in this file, right?
Yeah, that's true. Yeah, good point. Yep. So probably too much work there.
We're close here.
Yeah.
All right, so we have our three values here, and then as Chris was saying, we need to shove them into the pouch right here. So I think probably the easiest way to do this is just to make ourselves some kind of buffer. Or I just might call it buff. And I like to use sn print k for these. And we're going to print to our buff, to our size of buff. And then we basically need this right here. And let's just change this to, what is it? %G, Chris, maybe?
You mean to pull out the...
Yeah, to get to format the data correctly.
Yeah, I'm usually doing a little bit different, like I'm not sure about the G.
Well, let's give it a try. All right, and then I think that looks right. All right, and then we need the sensor value to double. Is that what we use? Oh, interesting. Okay. Did it manually here. I think I'm going to do it. Zephyr sensor has sensor to double in the API. Sensor value to double. I'm going to try to use this. right. And then we can take this part out here and just pass it our buff and our string length of buff. And missed a semicolon. All right. So if we go back and look at what we've been getting, our data has just been repeating over and over again with these 22s. Wait for the next advertisement.
And you'll see it in the payload as well, right?
In the payload, like on
the right side of the
here?
keyboard. Yeah, the hex dump. Yeah.
Yeah, we should. All right, that looked like it was data. And let's see if it was properly formatted data. It was, and there's our pressure, temperature, and humidity readings. So we got an actual sensor now pushing up to the cloud.
Awesome. So you've gotten the dialog 14695, which is a Renesas part that is now working over Bluetooth and using I2C bus to read sensors from external sensor. That's pretty cool. Sending back up to the cloud. That's great.
Yeah. And like I say, I think it's a lot of fun to actually push your own sensor data up to that. So we grabbed this part in order just to illustrate it. But really, any data you wanted to send to the cloud from your fleet at this point is on the table.
Yeah, that's right. I think, looking at the documentation for this part as well, there's a lot of interesting peripherals on it. Like it has like multiple 14-bit ADCs and just like on the actual dialog product page, it's definitely yet another interesting part. Just the richness of the Bluetooth ecosystem continues to amaze me in terms of what parts are out there, the low power profiles that they're still able to achieve, and just the things you can do with it. So it really, and now going back to a standardized gateway makes it even easier. So what do you think, Mike? Should people pick one of these up and try it out with the new Bluetooth service?
Yeah, I think so. I mean, this is a pretty easy one to work with. It is, there's a little bit of configuration involved, but all the stuff that we found is, there are breadcrumbs there for you to work with it. So I think the support is good, and Goliath makes it really simple to add it to your fleet. You might as well give it a try.
I think the only thing is just plug it in that USB stick upside down. Just try it 3 or 4 times.
Yeah. I think I did that every time I pulled it out today, Chris.
USB-C is the future, Mike. That's what I hear. So.
That's what I hear too. I'm waiting for those days.
Yeah. Well, great job on this. Thanks for getting this enabled, and we'll see people in the next one, enabling more parts on Goliath and Zephyr.